Let's tackle 13B, shall we? I'm on slide 2, which is a little bit of review in that we already established that it is not possible to repair or regenerate damaged neurons in the central nervous system, but it is possible, though not guaranteed, in the peripheral nervous system. And the condition that must be met in order to allow repair in the peripheral nervous system is that the cell body, the neuron's soma, must be intact. As long as that's not damaged, then repair is possible, but only, again, in the peripheral nervous system. Why is repair or regeneration impossible in the central nervous system? There are actually a couple of barriers in place. Oligodendrocytes are releasing chemical signals that are inhibiting the repair of neurons. And astrocytes are also physically barring the repair of damaged neurons. When repair is done in the peripheral nervous system, we already know that it's done via the efforts of Schwann cells, and they have to be sort of accessorized by the efforts of macrophages. Macrophages have to clean up the debris in order for Schwann cells to sort of lay down the now absent part of the damaged neuron. Moving to slide number 3, we need to start talking about spinal nerves. We've already talked about cranial nerves in person. We already know what a ventral root is. We already know what a dorsal root is. And thankfully, we already associate the word ventral with motor. We already associate the word, good grief, where am I going to squeeze this? Dorsal with sensory. Roots, depending on whether we're talking about dorsum or ventrum, they, how should we put this? They flay out into rootlets as the neurons are entering the spinal cord, whereas on the ventrum, the root begins as rootlets, and those rootlets converge into the ventral root. I think we had the roots on exam 3. Maybe the last page as well. So hopefully everything on page 4, slide 4, looks familiar. The gray matter of the spinal cord, the white matter or white columns of the spinal cord, the ventral root, right? Really a convergence of the ventral rootlets. These guys are rootlets. Okay. Versus the dorsal root. Here's the dorsal root, which diverges because it's headed into the spinal cord, into dorsal rootlets, okay? And you probably use the same landmark that I do for dorsum versus ventrum, and that's that dorsal root ganglion. The dorsal root ganglion is a nice indicator that, that side, if you will, is the dorsum. Now, we've been given something a little extra in this particular image that we haven't seen before, which maybe you notice. You see this vertical pattern here? Looks like it's climbing up and down the spinal cord and swelling out into these ganglia. I'm just making a mess. I'm not helping in any way. But how is that any different than most days, right? Okay. This is called the sympathetic trunk. We'll come back catch it automatically, but I just wanted to warm you up. And then these swellings are therefore called sympathetic trunk ganglia, where each one is a sympathetic trunk ganglion. And the sympathetic trunk is necessary in the thoracic region of the vertebrae because the ribs are in the way. So the sympathetic trunk sort of allows each spinal nerve, the nerves that are emerging, through that intervertebral foramen, from between two vertebrae, to sort of be linked together, to network, in other words. And that's also why these two little bridges are necessary, but we'll come back to those as well. Moving on to slide number 4. I actually just mentioned that roots either emerge or enter, because it all depends on whether we're talking about sensory or motor, the vertebral column via intervertebral foramina, which are really formed via two vertebrae, one stacked on top of the other. Those roots actually become longer as we sort of march down the vertebral column, and in fact, some of those lengths are long enough to make the inferior spinal cord look kind of like a tail, hence cauda equina. Okay, on to slide number 6. Spinal nerves, at least the portion that runs through the intervertebral foramen, is quite short, maybe 1, maximum 2 centimeters in length. And as soon as they exit, if you will, the vertebral column and are no longer encased in bone, then they likely branch. And when they branch, they initially give rise to a dorsal ramus, a ventral ramus, and a really tiny branch that's called the meningeal branch. Notice that I kind of faded it out on this slide. That's because we're not going to emphasize it. We're mostly worried about dorsal ramus and ventral ramus. The plural of those would be dorsal rami and ventral rami. And then we just saw the sympathetic trunk, which includes regularly arranged sympathetic trunk ganglia. Okay, these will help to network, specifically the ventral rami of just the thoracic region of the spine, because again, the ribs are in the way. Okay, and the bridge between the sympathetic trunk and different distinct spinal nerves are called, or bridges I should say, are called rami communicantes, that's plural. Ramus communicans is singular, but we'll play with those in a few slides as well and see them many times through. They're just helping to connect the sympathetic trunk with the rest of the network. Excuse me. All right, slide 7. Many of the things that we already went through, like rootlets and roots and gray matter and white matter, are labeled again here, okay? But what's new, what we really want to focus on, is that branching effort, okay? Spinal nerve was only this really short region that allows sort of a traversion through the vertebral column, okay? And as soon as that spinal cord, or spinal nerve, I should say, has, pardon the choice of words, but exited, now we're going to see a branching into dorsal ramus and ventral ramus. And in the thoracic spine only, we'll also see sympathetic trunk, okay, and connecting sympathetic trunk with ventral ramus rami communicantes. Okay, and we'll look at those again, don't worry. We're on slide 8. And personally, when I was you, this slide really helped me quite a bit to understand what's going on. So we're zoomed way out, looking at a transverse section, superior view, presumably, and this little region here would represent spinal nerve. Okay, we are in the thoracic region, and therefore this dot here represents one of the sympathetic trunk ganglia, and these branches here represent the rami communicantes. Okay, but what the real take-home message is from this image is that the dorsal ramus is far shorter, far less extensive than the ventral ramus. All of this is ventral ramus, ventral ramus, ventral ramus. Okay, and that's primarily because the thoracic and abdominal sela are in the way. So we have to wrap around the body in order to reach the ventral body wall. And so it's probably pretty clear just from this image that the dorsal rami, they serve the back, whereas lateral aspects and ventral aspects are served via ventral rami. Ventral rami have a much bigger job to do. All right, we're on slide number 9. Okay, and this is what I just mentioned, that the dorsal rami, they're just going to supply the posterior of the body, and even beyond that, just the trunk, okay? Whereas ventral rami, they supply the rest of the body, including the limbs, okay? Busy. You really want to be able to compare roots and rami because it's so easy to confuse. For instance, a dorsal root with a dorsal ramus. Roots are more medial in position. They're closer, in other words, to the spinal cord, and rami are more lateral or more distal. Okay, roots will converge, they'll merge in order to form spinal nerves, whereas rami are branches off of those spinal nerves. Okay, but I think what's probably most important is that roots are strictly sensory or strictly motor, whereas rami are not. They are mixed. Okay, so a dorsal ramus carries both sensory and motor information, whereas a dorsal root carries only, good job, sensory information. Nice. All right, moving to slide number 10, which looks really scary, but everything's going to be fine. Okay. This is actually all this yellow stuff here. This is a plexus. And you may recall, for instance, when we were in the ventricular system of the brain, that the word plexus simply means network. A choroid plexus is a network of capillaries, whereas a nerve plexus is a network of nerves. Okay, so here's a cervical plexus. Okay, moving on to slide number 11. Well, is kind in that you were provided with tables for each of the plexi. In other words, we have a cervical plexus, we have a brachial plexus, or really plexi since right and left. Pardon me. We have a lumbar plexus, we have a sacral plexus, and you might ask, why don't we have a thoracic plexus? Chances are you could probably think about it and actually answer that question yourselves. That's right, the ribs are in the way. Okay, so if this is the cervical plexus, okay, on slide 10, then slide 11 is tabulating the different specific nerves that branch off of that plexus or comprise that plexus, okay? And if you look at this table and you're under the impression that you have to know all of it, then maybe it looks okay until you move on and you see the other plexi. So for instance, slide 15 shows all of the details of the different nerves that make up the brachial plexus, and now you're panicking a little bit, right? And slide 17 shows all of the all the details of the nerves that make up the lumbar plexus. Slide 19, all of the details of the nerves that make up the sacral plexus, okay? So it looks like you have a lot of work cut out for you, but let's double check. I'm going to check the final exam study guide. Always a good idea to look at the study guide alongside the lecture. Let's see, this says cervical plexus, phrenic nerve. Oh, there's it. There's the phrenic nerve, okay. What muscle does it innervate? Oh, I actually already know that because I had to learn for practicum 1 that the phrenic nerve innervates the diaphragm. Or if you have a hard time spelling diaphragm, you can pronounce it diaphragm. Sometimes that helps. Or just makes you sound silly. And then, what else does this say? List other nerves. So I have to be able to list the other nerves in the cervical plexus. And then it says nothing. In other words, all I have to know for the cervical plexus or plexi left and right, I have to know specifically what structure is innervated by the phrenic nerve, and I simply have to be able to list all of the nerves. That's it. I won't ask you for anything else. Okay? Let's move on, therefore, to the brachial plexus after we take a brief pit stop at slide 12. Sorry. I think I've actually already mentioned in class for you that hiccups are a byproduct of irritation of the phrenic nerve. When the phrenic nerve becomes I don't know what's the right word, displaced or crushed or irritated in some sense, then we're likely to see spasming of the diaphragm. That's what hiccups are. Moving on to slide number 13. We're actually skipping this slide and the visual support for it that's on slide 14 because it's immensely confusing for students. So let's just get rid of it. But certainly know that slide 14 is a depiction of the brachial plexus. Just don't worry about those colors. Don't worry about those different sort of levels of branching, okay? So here's the table for the brachial plexus. So I'm looking at the final exam study guide, and I'm just double checking. It says brachial, 4 main branches. Oh, well, these are the 4 main branches, and my teacher just told me to cross those out, so I don't need to know that. And then it says musculocutaneous nerve. Oh, there it is. List at least 3 muscles it innervates. Well, for practicum 2, I had to know 2 of the muscles it innervates. So I already have biceps brachii down. I already have brachialis down. All I have to do is add coracobrachialis. Okay? Then it says axillary nerve. Oh, there it is. Okay. Innervates muscles in what area? Are you kidding me? Really? Oh, well, that's from chapter number 1. Axillary, what area is that? It's the armpit. That's literally all you have to know about that. And then it says, pectoral nerve. Oh, there it is. Pectoral nerve, okay. Which muscles does it, are you kidding me? Which muscles does it innervate? Hello! Pectoralis major and minor. Good grief. And then it says, list at least 2 nerves which innervate muscles of the hand. List at least 2 nerves which innervate muscles of the hand. So I'm going to look for words that make me think hand. Oh, palm, that's part of my hand. Fingers, that's part of my hand. Oh, Queen's hand. Oh. Oh, fingers. That's part of my hand. That's all that's popping for me. And I have to be able to list it. Oh, okay. So I have to be able to list two of these three. Two of the list of three: median, ulnar, and radial. Well, personally, I already think of ulnar and radial as together, right? Because the ulna and radius sit right next to each other. So that doesn't seem so evil. And so now I'm just double checking. What else does the final exam study guide say about the brachial plexus? Oh, nothing. So that's literally all I have to know. All right, slide 16. This is a depiction of the lumbar plexus, and I want you to know in general what a plexus looks like, but it's not as if I'm going to show you any of these plexi and ask you to point out the nerves. That sounds horrid. Moving on to 17, there's the table that lays out the lumbar members or components, and I'm looking at the final exam study guide, and it says lumbar plexus. Which rami? Are you kidding me? Wow. Okay, well, for all of these, the relevant ramus is the ventral ramus. If I go back and look at slide 15, which ramus? The ventral ramus. If I go back and look at slide 11, which ramus? The ventral ramus. Okay? That's a kind of a duh question. It's only the ventral ramus that's long enough, extensive enough to branch this highly. Okay, and then this says, learn muscles innervated by one nerve of your choice. Good grief! Who is so spoiled? It's you. So, I don't care which one you choose. That's totally up to you. If you think one is easier to remember because it's easier to pronounce, or it's easier to remember what's going on, a lot of people choose this one just because it's like maximally dirty. Whatever. I don't care. I really don't care. Just one. And you have to know which good grief, where did my brain go? Oh, which muscles are innervated, okay. And then after that it says nothing. That's literally all you have to know. All right, here's a depiction of the sacral plexus on slide 18. On slide 19, there's the matching table. All right, so I'm going back to the final exam study guide, and it says sacral plexus. Which rami? Honey, duh. Ventral ramus, ventral ramus, ventral ramus. Sciatic nerve, it says, innervates muscles in what area? In what area? That's it? Okay. All right, let's look. What do all these words have in common? Knee, leg, foot, thigh, leg, foot, leg, foot, thigh, toe, lower limb. That's all you need to know. Your leg. Good grief. And then it says inferior gluteal. This guy. Which muscle does it innervate? And that's actually a little counterintuitive. Even though it's called the inferior gluteal nerve, it actually innervates the gluteus maximus. So it's a little bit flip-flopped, okay? And then for sciatic nerve, it says nothing else. That's all you have to know. So we're not allowed to freak out about spinal nerves. I think the trickiest parts are the rami communicantes and the sympathetic trunk. All right, moving to the next slide, which is number 20. Dermatomes are the regions of skin that are also innervated by branches of spinal nerves, and almost all of the spinal nerves participate in establishing the dermatomes. Knowing where the dermatomes are often allow us clinically to assess which spinal nerve is potentially being affected. Okay, so where along the spinal cord has something gone wrong? So if we look on slide 21, this is sort of like a map or a figure of the different dermatomes, okay, where the green depict the dermatomes sort of served by the cervical plexus, the kind of pink on the mostly rear end represent the dermatomes served by the sacral plexus. Okay, now I need you to know what a dermatome is, but I don't need you to know that the penis, for instance, is served by sacral nerves 2 and 3. Who cares? I'm never going to show you this image again. I don't need you to be able to label it. I just need you to know what a dermatome is. Okay? I mean, even clinically, someone who is using dermatomes is probably going to refer to the map. It's not like anybody memorizes it. That's just kind of silly. So anywho, that's the end of 13B.